Hello everyone, welcome to the problem solving session of Principle of Physics 1. In this session we'll talk about the motion in 1D. So in our theory part we already discussed about that motion in one dimension. So what would be the position, what would be that velocity, acceleration, instantaneous velocity, instantaneous acceleration, average velocity and average acceleration. That's the thing we are going to mathematically find out. So for example, in this problem, a particle is traveling towards the x direction with the equation that is given, that the particle is traveling according to this equation. So where that displacement equation is given, x equal to 4 minus 12t plus 3t square, where t is in second and x in meter. Now in the first question they asked me to find out the displacement of the particle in time interval t equal 0 second to t equal 3 second. Fine. Now the displacement for a particle we can express by the equation, say that del r is basically x2 minus x1 I hat. So 1 and 2 subscripts is indicating the position at time t1 and t2. So I'm writing in a general equation, then I'll modify according to my this equation. So plus y2 minus y1 z hat plus z2 minus z1 k hat. So this is actually the general equation of the displacement of a particle which is in the three-dimensional case. Since we are dealing with right now 1D case, so that's why I'll drop out that y and z component. So for our case, so del r, in that case the displacement equation, since they are asking me to find out the displacement in between time t equal 0 second to t equal 3 second, so that's why I'll write it should be x3 minus x0 or x0 I hat. So that should be my displacement equation. Fine. Now I have to find out that x0 and x3. What is x0? The position of the particle at t equal to 0 seconds. So that means I will just plug in t equal to 0 in that equation. So if I put that, then what I'll find out 4 minus 0 plus 0. So that means x0 would be that 4 meter. Same way, and x3, I'm just plugging the t equal to 3 into that equation. If I do that, then I'll find out 4 minus 36 plus 27. So that will give me x3 would be basically minus 5 meter. Minus 5 means it's basically towards the negative direction. So in that case I can find out the displacement. So the displacement is a vector, right? But the distance is a scalar. So displacement del r would be minus 5 minus 4 I hat, which is basically the minus 9 I hat meter. So this is actually the displacement in between time interval t equal to 0 second to t equal to 3 second. So this is actually the answer of the first question. Fine. In the second question, what is the average velocity of the particle in this time interval t equal to 0 second to t equal to 3 seconds? So average velocity we define by the formula, the general formula to find out the average velocity in between any time interval. We write down average, v average would be del r, which is the displacement, divided by del t, right? So that's how we can write down. So we find out the del r, which is minus 9, and del t would be difference of the time, which would be 3 minus 0 into I hat, and the unit would be meter per second. So right, so that's why it should be minus 3 meter per second I hat. So that should be that average velocity of that particle in the time interval t equal to 0 second to t equal to 3 second. So this is should be answer. V average is minus 3 meter per second I hat. So this is the answer number B. Fine, we find out that average velocity of that particle. Fine. Now the third question, what is the velocity of the particle at t equal to 1 second? It is basically they are asking to find out the instantaneous velocity, right? At the time t equal to 1 second, what would be the velocity of that particle? And also they are asking a tag question, is the speed increasing or decreasing just then? So that's mean at t equal to 1 second, whether the speed of that particle is increasing and decreasing. Speed is a scalar quantity, right? That we can find out if I just find out the velocity of that particle. Okay, first I'll find out that velocity, so which is basically that instantaneous velocity of that particle. So C, so instantaneous velocity we can find out V would be so dx over dt I hat, right? So that's when I have to take the derivative of the function. If I do that, what I'll find out 0 minus 12 plus 60 I hat, or V is, I'll find out 60 minus 12 meter per second I hat. So this would be that velocity as a function of time. Now at t equal 1 second, so V would be V1. I can write the subscription 1 stand for the velocity as 1 second. It should be 6 minus 12 meter per second I hat, which is basically the minus 6 meter per second I hat, which is that instantaneous velocity of that particle at t equal to 1 second, right? What about whether at t equal to 0 second, what would be that velocity? Because I have to find out whether it is increasing or decreasing, right? So we can find out, say that at t equal 0 second, in that case I just put the value t equal to 0 into that equation. I just put the t equal to 0 into that equation. If I do that, then I find V naught is would be minus 12 meter per second I hat, right? So that means velocity at initially was 12 meter per second, and 1 second is minus 6 meter per second, right? So what about, so that's mean it's decreasing, its velocity is increasing, right? So velocity is t equal to 0 second is minus 12 and 1 second is minus 6. That means it's approaching towards the positive number. So the velocity is a vector, it has magnitude and the direction, right? So that's why I can say that it is basically increasing. What about the speed? Speed is a scalar quantity, so that's mean I have to take that magnitude of that one, right? Initially the speed V naught is 12 meter per second, V1 is 6 meter per second. And what about, say that the V2, if I write down the V2, say V2 vector, the velocity at t equal to 2 second, so which is going to be that 0 meter per second, right? So that's mean at that time equal to 2 seconds, the velocity is basically the 0. Then I can say the speed is also 0 meter per second. So that's mean the speed is basically that decreasing. Velocity is increasing, is coming from negative 12 to basically that positive number. Velocity, then I can say that velocity is increasing, but speed is decreasing, right? So I can say at the time at t equal to, they ask me at t equal to 1 second whether it is speed increasing or decreasing. I can say the speed is basically that decreasing. What about if I say at t equal 0, t equal say that 3 second, v3 would be right now, it should be that plus 6 meter per second, plus 6 meter per second ahead. So right now the velocity is increasing, right? And speed will be also that increases. So we can say that velocity is greater than 0 always for t is greater than 3, right? But for in the case for 0 to 2 seconds, basically the velocity is decreasing, right? So velocity is less than 0 for t greater than 0 or equal or less than 2. So that should be that velocity in between that interval, we can find out that way. So this is actually that answer number C. What about that D? Is there ever an instant when the velocity is 0? If so, give the time. We can already find out, right? T equal to 2 seconds is velocity is 0, right? We can mathematical also find out. Say I find out that velocity general equation, which is minus 12 plus 60, right? I had now say I have to find out what the velocity would be 0. I'll just put that 12 plus 60 equal to the 0. Then I can say that the t would be 2 seconds, right? Since I already find out that t equal to 2 seconds, the velocity of that particle will be the 0, or we can say that it will be momentarily stopped. Probably it's changing its direction at t equal to 2 seconds. At t equal to 2 seconds, it's changing its direction, so that's why the velocity is 0 at that moment. Fine. Calculate the instantaneous acceleration of the particle at t equal to 4 seconds. So to find out that instantaneous acceleration of the particle, we can find out, say, instantaneous acceleration. A would be basically, I have to take that dv over dt, or I can take the second derivative of position, right? So that should be my instantaneous acceleration. If I take that one, I'll find out, say that that would be basically that plus 6 meter per second square I had. So that's mean instantaneous acceleration will be the same, it is independent of that time. So that's why we can also say that the particle is traveling at a constant acceleration. Why? Because if you change the time with respect to the time, the acceleration is not changing, but the velocity will be the change, because velocity is a function of time over here. If you change that t, your velocity will be that difference. So that's mean the velocity is not constant, velocity is changing, but the acceleration is constant. So that's why we can also say that the particle is traveling at a constant acceleration. That is also answer of the question of the E. Sorry, this would be basically that E. Okay, thank you very much.